Hi everyone, my name is Zach Slagle. I'm co-chair of the Forage Task Group along with my counterpart Mike Thorne. And today, on behalf of the task group, I'm going to be talking status of the forage fishes in Lake Erie. For this portion of the LEC meeting, I'll be presenting on lower trophic, forage fish indices, sport fish diet and growth, hydroacoustics, and invasive species. I'll start with lower trophic and describe the nutrient conditions in the lake. To describe the nutrient levels in the various areas of the lake, the Forage Task Group uses a combination index of transparency, nitrogen, and phosphorus to yield a trophic status index. Here's a graph showing trophic state index over time. The most important thing to remember is that higher on the graph indicates greater nutrient levels. So eutrophic up top, mesotrophic in this gray in the middle, and oligotrophic, which is the lowest nutrient level on the bottom. You can see the West Basin, shown here in red, came down from a high level of nutrients, but was still classified as eutrophic in 2021. In yellow, the Central Basin was classified as mesotrophic, but just barely. And moving over to New York, both offshore and nearshore were classified as oligotrophic, but are on a 3-year increasing trend. Moving on to forage fish trawl indices. In the next few slides, I'll be presenting data from 4 different trawl surveys. In the West Basin, we have the interagency survey that is conducted by both Ohio and Ontario. In the Central Basin, we have Ohio data. In the East Basin, we have both New York DEC data and Ontario data from Long Point Bay. I'll be presenting both survey totals, abundance totals, and species-specific totals. On the next 4 graphs, I'm going to show you total forage abundance for each trawl survey. We group forage species into groups to just help us visualize. So we're going to be looking at a red is clupeid, so this is gizzard shad or alewife. Spiny rayed fishes are walleye, yellow perch, white bass, white perch, that kind of thing. And in blue, we have soft rayed fishes. That includes emerald shiner, round goby, and here it includes rainbow smelt. For the West Basin survey, this is the interagency survey with Ontario and Ohio data combined. We had the highest forage number that we've seen since 1989, seen here. That was 4 times the last year's number and twice the 10-year mean. However, that was driven by one outlier catch, one large catch of white perch. But even if you take that out, we still had a very high abundance of forage fish in the West Basin. Moving over to Ohio data from the Central Basin, we're adding in another color here. We're breaking out rainbow smelt from other soft-rayed fishes because rainbow smelt are much more important in the Central and East Basins. In 2021, we had the largest forage catch in about 4 or 5 years. That was mostly driven by a large catch of young of year rainbow smelt, seen here. Moving over to trawl data from New York DEC in the East Basin, we had a very large forage catch in this survey as well. That's mostly thanks to a very strong young of year smelt year class, just like Central Basin. But New York surveys also showed strong catches of yoy walleye, yoy shad, and alewife. Unlike the other 3 trawl surveys, in Long Point Bay, we did not see an increase in forage fish abundance. It's been relatively low but stable for the last couple years. The only real note is that round goby abundance was higher than usual. Moving on to species-specific trawl results. Here we have rainbow smelt young of year, so rainbow smelt that were born in 2021. This big peak in yellow is one of New York's largest catches of rainbow smelt yoy. We also had a strong catch of yoy in the Central Basin, but the Long Point Bay index was pretty low. When we go to look at rainbow smelt adults, we had low catches of adults across the board. Particularly surprising for New York because we had this large peak last year. But if you look at the whole time series, we've had quite a bit of variation in catches for this species and age class. For all ages of emerald shiner, unfortunately, all of our surveys continue to show very low abundances of this historically important forage fish. For the last 6 to 7 years, with 2018 New York being the one exception, emerald shiner indices have been low across all surveys. In 2021, Gizzard Shad young of year indices were relatively low across the board, although the East Basin New York survey and Long Point Bay had relative highs within the survey, but overall low abundances. Finally, we're now looking at trawl results for the invasive round goby. In 3 of our 4 surveys, we had above average catches in 2021, with Central Basin being the only exception. Now we'll move over and look at sport fish diet and growth for walleye and lake trout. Starting off with walleye diets in the West Basin, these are taken from Michigan Trawl Survey data in August. You can see that walleye eat a variety of species. We've got gizzard shad in green, white indicates white perch, and yellow is yellow perch. Blue indicates unidentified fish. In 2021, we had a good mix of the 3 identified species. Here's a look at walleye diets in 2021 from fall gillnet surveys that Ohio DNR conducts. You can see that both in the West Basin and in the Central Basin, gizzard shad are making up the vast majority of diets, with a much smaller percentage of white perch, emerald shiner, and a little bit of walleye round goby. On the east side of the lake, we see a different picture for walleye diets. So these are angler caught walleye from New York DEC surveys, looking at percent by volume. This blue color indicates rainbow smelt. In many years past, they were predominantly feeding on rainbow smelt, but round gobies have been showing up more and more in their diets, up until last year where we saw another big increase in rainbow smelt, which matched up with New York trawl surveys showing a big increase in adult rainbow smelt. This year, we're back down to around 30% rainbow smelt and around 60% goby or so seen in this orange color. Focusing on walleye growth, here are walleye length at age plots for ages 2, 3, and 4. In general, for the last few years, we've seen declining length at age, indicating a lower growth per year for these age 2 and age 3 fish, and to a lesser extent age 4, potentially because of the large walleye population in the lake and competition with each other. Here we're looking at the same data source, fall gillnet surveys in the Western and Central Basin, by age, but here we're looking at walleye conditions. So for a given length walleye, how fat is that walleye? We see a general decline over the last few years for ages 2, 3, and 4, but it's not as steady of a decline compared to length at age. Now we'll switch over to lake trout briefly. This is a diet graph, again showing percent occurrence of prey items on the y-axis over time. This blue color again indicates smelt. So lake trout are mostly eating smelt. This is kind of a return to the time series normal that we've seen from a couple of years where they're eating a lot of gobies. Here we're looking at lake trout growth, length at age 5. In the last couple of years, we've had a rebound from some time series lows. Moving over now to results from hydroacoustic surveys in Lake Erie. Hydroacoustic surveys in Lake Erie have been undergoing a redesign. So in the last 2 years, biologists have been evaluating and comparing different designs. The previous design were these cross-basin transects where the vessel would have to travel all the way across the lake overnight. As you can imagine, that takes a really long time, and we also had to have pretty much perfect weather conditions for that. Right now we're trying out, in the last 2 years we've been doing some of these cross-basin transects and also adding in some random grid elements shown in orange here. These are being evaluated because they would allow us to spend less time surveying and also utilize a wider variety of weather conditions. So in 2022, the goals are to complete the evaluation of the last 2 years comparing between these 2 surveys, and we're likely moving to a grid survey because the initial results have been very good. As for results from 2021, the West Basin Hydroacoustic Survey does not apportion by species, so we're just looking at total forage density and biomass here. But for forage fish size targets, We had the highest densities that we've seen since 2015, shown here in darker gray, but the biomass is pretty low, so these targets were fairly small. For the East Basin Hydroacoustic Survey, midwater trawling does take place, so we can apportion by species. So these results here, this is a time series of only adult rainbow smelt. You can see in 2021, we had lower numbers of adult rainbow smelt than we did in 2020, but they're still pretty moderate compared to the previous couple of years of very low abundances, and these are higher abundances than perhaps we saw in the trawl. Finally, let's take a look at some invasive species of note in Lake Erie. Our Fish and Wildlife Task Group members, Greg Wright, Kristen Town, and their crew were able to sample the American waters of Lake St. Clair, much of the Detroit River, and a lot of the Ohio waters of Lake Erie, using a total of 7 different methods of capturing fish. The first of 2 species of note that Fish and Wildlife captured this past year is Nile tilapia. They captured 1 adult individual here in the Gordon Park area of Cleveland. Nile tilapia are not native to North America, but they are tropical species and are unlikely to be able to overwinter in the Great Lakes. So no official ODNR response was taken. The second species of note is red ear sunfish. 2 adult individuals were captured, 1 in the Black River area, Lorain, Ohio, and 1 in Maumee Bay over here. Red ear sunfish are native to the southern states and not native to the Great Lakes region, but they have been captured before by Ohio DNR and are found across Ohio as stocked fish. So this is unlikely to be a threat. A couple of quick notes on Forage Task Group work in the upcoming year. First off, we're looking at trawl summaries. We're going to look at redefining the West Basin strata because that hasn't been revisited in about 15 years, and the current strata that we're using may not make sense. We're also looking at how best to deal with hypoxia. This has been an ongoing concern, and it has affected a lot of our trawl surveys, but we don't have a great way of dealing with it. We are working towards using the new survey, the new random grid design survey, and the hydroacoustics team is also working on developing programs that take the subjectivity out of the hydroacoustics analysis. And our aquatic invasive species team is moving towards data sharing with the USGS non-indigenous aquatic species database that's already being maintained. And task group members are also looking into sharing their own data with this database. In summary, in the West Basin, we had a large increase in forage. That was seen in both our trawl data and in our hydroacoustics data. In the Central Basin, a large smelt young of year class came in and drove the forage to the highest it's been in the last 5 years or so. And in the East Basin, we had that same smelt year class show up in New York surveys, driving a very large total of forage. However, in Long Point Bay, the forage base remains relatively low compared to the rest of the lake. If you're interested in more information than I've summarized here, we go a lot more in depth in our written report that will be coming out soon. And for the time being, we have our executive summary available as an online handout. Thanks for your time.